Picture this: warm, gooey cookies just out of the oven, crunchy candies in bright wrappers, a slice of velvety chocolate cake, or an ice cream cone dripping in the summer sun. Is your mouth watering yet? Why do sweet foods have such power over us? And what exactly happens in the brain that makes sugar so hard to resist? Sugar is a catch-all term for a wide group of carbohydrates: glucose, fructose, sucrose, maltose, lactose, dextrose, even starch. You'll also find it under names like high fructose, corn syrup, raw sugar, fruit juice, or honey. And it isn't just in desserts. Sugar is hidden in yogurt, tomato sauce, granola bars, flavored waters, even dried fruit. Since it's everywhere, understanding how sugar affects the brain is critical. The moment sugar hits your tongue, sweet taste receptors on your taste buds fire a signal up to the brainstem. From there, it travels to the cerebral cortex, where different regions decode bitter, salty, umami, and sweet. Then, a powerful circuit kicks in: the brain's reward system. This network of neurons and chemicals is designed to answer one question: should I do that again? That warm, happy feeling from a bite of chocolate cake. That's dopamine, telling you, yes, repeat this. But sugar doesn't just stop at taste. As it moves into your stomach and intestines, there are more sugar sensors, not taste buds, but receptors that signal fullness and tell your body to release insulin. These signals also feed back to your brain, reinforcing the experience. Dopamine is the currency of this reward system, and sugar is one of the few foods that reliably increases it. Broccoli, nothing. But sugar lights up dopamine hotspots in the forebrain. The same brain regions triggered by alcohol, nicotine, or heroin, though, of course, not nearly as extreme. Still, the parallel is striking. Sugar can act a little like a drug. Here's why. Imagine you eat a healthy, balanced meal. Dopamine levels rise in those reward hotspots, but if you repeat the same meal day after day, the dopamine response fades. Your brain evolved this way to encourage varieties, so you notice when food has gone bad. And so you get a wide range of nutrients. But sugar doesn't follow that rule. If you eat sugar-rich foods often, the dopamine response doesn't level out. Each time, it keeps lighting up the brain as if it's something new and exciting. That's why sugar is uniquely addictive among foods. Doesn't get boring. The problem is that over time, constant stimulation of the reward system can trigger a cycle: cravings, loss of control, and tolerance. You need more sugar for the same buzz, and the habit reinforces itself. Meanwhile, your gut is also playing along. Those sugar receptors in the intestines keep sending signals, pushing your body to release insulin and deal with the excess sugar in the blood. If this happens too often, it can disrupt your metabolism, contribute to insulin resistance, and raise the risk of diabetes and other diseases. But let's be clear, sugar itself isn't evil. Our brains actually run on glucose, a simple sugar, as their main source of fuel. The real issue is how much and how often. A wedge of cake at a party, no problem. But constant overconsumption hijacks the brain's natural balance. Think about it like this. Sugar isn't just about sweetness. It's a carefully wired system that starts on your tongue, runs through your gut, and ends in your brain's deepest reward circuits. Too little sugar, and life feels bland. Too much, and the brain treats it like a drug. So, the next time you crave dessert, remember what's happening inside. You're not just eating cake, you're feeding a chemical conversation between your tongue, your gut, and your brain. And like any conversation, it's healthiest when it's balanced.